The HVAC system that we're installing in our house is known as a ductless mini-split system. This is because these types of units usually have no ductwork at all and are split into two main components: an indoor fan and evaporator unit called a head for each room, and an outdoor unit which has the compressor and condenser. Now, ordinarily, an HVAC system is pretty much all in one big package with lots of ducts, and it takes up a lot of room. But these are split up into two small units, hence mini split. The first part of this system to be installed are the refrigerant lines that connect each head unit to the outdoor unit. These are two malleable copper pipes, well insulated, that carry the gas to and from the outdoor unit, which houses the compressor and condenser. Along with these refrigerant lines, there's a control wire, so the two units can communicate. This control wire powers the indoor unit also, so you don't have to have your electrician run another power line to each of the heads. I'll just point out that for our system, all of our upstairs head units are sharing the same outdoor unit. So all of these refrigerant lines exit the house in the same place and will hook up to the same unit. Under the house, we have something that I had never seen before. It's a ducted, ductless system, and it will heat and cool the entire downstairs. This unit pushes the air through ducts which were installed before the framing of the house. Since this unit and the ducts are in the crawl space, they need to be carefully sealed and insulated. As you can see, we've got a luxuriously spacious crawl space down here. And it's a real feature of this type of construction. The plumbing, the ducting, the electric, pretty much everything mechanical can be accessed from right down here in the crawl space. This unit is particularly well suited to our house and our crawl space because the access panel to work on the unit is on the bottom. And as you can see, there's plenty of room down here. It's very easily accessed, along with all of the other components of this system and the plumbing system as well. If there's ever any trouble with the ducting, it's going to be very easy to get to it and repair or replace it. Now, if this was a crawl space with limited access, we could well have done all the ducting in sheet metal. We could even have considered a conventional heat pump system and located this air handler somewhere else completely, probably inside the house or attic somewhere. Each of the head units upstairs and the big unit in the crawl space create condensation that has to be drained away. So the next task is a lot like plumbing. It's creating a small drain system so each of these units can condense and send the water away from the house. Each of them goes pretty much straight down and into the crawl space. We put a footing drain down here when we put the foundation in to begin with for just this reason, so that this or any other moisture that gets into this crawl space has a place to exit quickly and permanently. So if you're worried about this strapping that they're using to hang the ducts and drain pipes, stick around till the end of the video. We've got a good demonstration that should put you at ease. We're going to torture test this stuff and show you what it's capable of. The outside units that will sit here consist of several parts: a condenser, a compressor, a fan, a motor, the shroud. And once they're installed, we're going to give you a closer look. But let me just say right now that the thing that sets these guys apart is not their muscle, it's their brains. The copper pipes inside this white sheath are not very big. They're 1/4 of an inch in diameter. And you got to be gentle when you're moving this stuff around and treat it with care. You should never be yanking or tugging or bending it, just sort of gently lifting it and pushing it along so you don't cause a leak. HVAC work and sheet metal work go hand in hand. And for that reason, the installers take care of the other ducting items for us, even though they're not a part of the heating and air system, while they are here. In our house, that means bathroom, fan, vents, a vent for our range hood, and a dryer vent. Usually, these vents are moving air that is very moist, super moist, especially the dryer and the bathroom vents, so it's really important that it gets clear out of the house. Make sure the ducts are sealed tight. If moist air escapes and condenses, it's going to create a place where mold can and will grow, and nobody wants that.
I was talking about that. That's what
So the ducts coming out of the bathroom fans are insulated like this because there can be a real difference in the temperature between the air coming out of a bathroom and the air in the attic in the wintertime. Having it insulated and carefully sealed up is going to reduce the condensation which otherwise could eventually find its way into the attic and create an opportunity for mold. This is the return air duct, which is an air intake for the downstairs system. It pulls conditioned air right back into the system from the downstairs as opposed to pulling it from the untreated crawl space air. Later on, you will see this get a nice trim piece and an air filter, and it will look very familiar. So I have always been really pleased with the guys at Mahalo Heating and Air Conditioning. They're tidy, professional, on time, on budget, they deliver what they promise, and in this case, they're totally cooperative while we film them work and then show their work to the whole world. I salute Tom and his guys, and I want to thank them for being a part of all this. I've been a customer of Tom's for the last 12 years, and this job was just like all the rest. Now, full disclosure, there was no part of this work that was sponsored or comped in any way. But when I build again, I will be calling Mahalo 100%. If you happen to live in the area around Roseburg, Southern Oregon really, and need HVAC work, check them out. And if you live somewhere else, you got to be wise when you decide who's going to do this work for you. I wrote an ebook that you can pick up on Amazon that helps with the process of selecting a contractor. It's only $5, and it might just save you a real headache. So check that out if you're getting ready to partner with a contractor of any kind. It's very common to hold up ducting with steel strapping. I mean, there's all kinds of struts and, steel can hold up ducting very nicely, especially solid steel ducts. And a lot of you have had real questions about why in the world would you use that black nylon stuff to hold up the ducts and the line sets in areas where you never want to have to get back in to fix it. Fair comment. We didn't use steel, even though I love steel, but we're going to put this to a test so you might have some idea of just how strong this stuff really is. So bear with us on the noise. We've got a windstorm and a rainstorm, and it's noisy in the old tin shop. But the plan is to lift this 150-pound Peter Wright anvil with the same black ribbon and a total of 6 staples. And if it'll do that, I'm not going to have any problem sleeping, and you shouldn't either, about whether or not this stuff is adequate for the test of holding up, just a few pounds of flex duct and line sets. Let's see how it does. So thanks for hanging with us. This is a long video, but I think it was worth demonstrating to you that this is a good system. But in any case, you may not be used to seeing inside this shop. This is where I do my blacksmithing. If you go back in our archives, we've got plenty of videos that we've made in here, and we've got plenty more in the months and years ahead. So check that out. But as always, thank you for watching Essential Craftsman, and keep up the good work.
Basically, I just want to explain what we're doing for the lower level of the home. We're putting in a ducted, ductless dike and heat pump system. So it's a single zone variable capacity heat pump that'll sit outside, matched to a very particular dike and air handler that sits right here. Well, the reason we put the ductwork in before the house is built is honestly because that's what the county makes us do. We have to put our initial duct system in before the floor is put on, simply because the inspectors will not crawl under here and inspect it later. Therefore, we do not go to a tremendous amount of effort to do a beautiful job on our underfloor duct system because we know we're going to have to fix some of it. Here in Oregon, it rains. Ductwork's going to get wet. 9 times out of 10, we have to replace some of the duct runs. We have to reseal things. So that's why it is the way it is right now. It's a very simple duct system. It's mostly sealed. Now that the guys are here doing the top out portion of the job, they'll finish the sealing, they'll finish strapping up flex. They'll actually mount the unit right here. This plenum, I know it looks very odd size-wise, but it is meant to fit the unit that we're going to put in. This is
the handler itself, or the unit slides in there?
it attaches right to this flange right here,
Oh,
which
okay,
got
blows in
kinked.
there.
Yeah, this is actually a 24 gauge plenum. It's going to be fine once the unit's connected. Once we get the unit in, we'll also do the return air duct. So obviously we couldn't do that before because the unit's not here. So it's kind of it's just the way the process works. But hopefully I don't see any damage right now. Hopefully everything's going to be fine. Yeah, and this is a nice big crawl. There's plenty of room. The unit that we're actually putting in here normally wouldn't go in a crawl space because the service access panels are from the bottom. In this situation, we have lots of room, no problem working on the unit. You wouldn't want to put it in a tight attic or someplace where you couldn't get to the bottom of the unit. So this is an ideal setup for this type of unit. The other thing with this unit, they do not require an extended length reducing plenum. You can do a nice short plenum like this. We can adjust all the airflow settings, the static pressure settings, everything in these units. You can even, with these units, they're pretty cool. You can actually put round starter collars right on the very end of the unit and build in zoning dampers right into it. So you don't really have to have any ductwork on these. This is actually more than we normally do on this type of unit. We could have done totally ductless. The reason I went with this unit is because the main level of this house is basically one open floor plan. We have a couple little rooms, but it's basically we're just dispersing air into one main zone. We don't really need to balance it. You don't need specific temperature control in different rooms, so it was a good fit. The flex duct was chosen. There's nothing wrong with flex duct as long as it's sized properly, strapped up properly, which, again, we'll go through and make sure everything's properly strapped. Everything is slightly oversized for distances. We didn't do steel on this. 2 reasons. Steel ducting is great, but it's expensive, much more cost. And in this situation, we've got, 4 feet of crawl space here, so there's never going to be problems with rats or mice or possums or anything getting down here. So this is fine. There's nothing wrong with it. Another thing, you'll notice we hung the main plenum here with this nylon strap. Some people would want to do steel strap, but this strapping is actually rated at 600 pounds per square inch. So considering we're hanging maybe 75 pounds here, more than adequate. There's absolutely nothing wrong with that. And then we use it on all the flexible duct as well too. So, and the nice thing about this is if we need to, once we get the unit in, if this doesn't quite line up, we can just easily cut these, mount it, rehang it, but it's plenty. The unit will be hung with strut and all thread, so it's hung right from the structure here, very stoutly. Here we have one of our main ducts. I'm not sure which room is right above us here, but regardless of how the ductwork is installed, whether it's flex or steel, ideally you want to have it as straight and as few bends as possible. Especially with flex, the more kinks and bends and twists and turns, it just chokes airflow. So you obviously don't want that. This one here is fine. We might add a couple more straps now that we're doing our top out portion. But then over here, you'll see our floor boot up in here. Nothing is sealed. The ductwork is not yet connected. And there's a big reason that we do that. And the reason is if we do that at our initial rough in, this thing is going to be completely full of debris, construction dust, filth, dirt, God knows what. So we leave all these completely disconnected. We won't even finish them up until we're here to do our final. At that point, the boot and the elbow, all this will be mastic sealed. The elbow will be turned 90 degrees and this flexible duct will be connected to it, sealed with mastic, and then strapped with a Panduit strap with a giant zip tie. So that's why this is like this for now. Yeah, there are schools, but honestly, doing it is, in my opinion, doing it is the best way to learn it.
Yeah.
Like, for instance, my background is actually sheet metal fabrication, and when I started in this 30 plus years ago, I didn't know a thing about sheet metal. I went into the trade as an apprentice to the fellow who ran the shop at a place I used to work, and I learned it by doing it. Started at very low wages, and here 33 years later, here I am.
So you started with just more of the sheet metal expertise, and
Correct,
then kind of
right.
had to pick up all
Right.
the other
I picked up
things.
everything else along the way. You know, the coordination, the scheduling, the purchasing, then in design and sales, and now having my own company, I have to do everything. I'm not a service technician, so I'll never claim to be one, but
Yeah.
pretty much everything else I can do.
So what percentage of your work is like service calls versus new installs and such?
Installs are probably 70% of our business, and the rest would be service, I
Yeah.
would say, yeah.
Okay.
And we're mainly residential, don't do much commercial work.
So if there was a young guy interested or asking you, should I get into being a HVAC tech? I mean, what's like the career outlook and overall like?
Oh, the career
like
outlook's...
the trade profile.
Yeah, the career outlook's incredible. I mean, if you're especially, well, installers or technicians, I mean, once you know how to do it and you have a good work ethic, you can go anywhere in the world and get a very good paying job.
Yeah.
I mean, they're incredibly in demand. We have a hard time getting people all the time. Getting people to have the knowledge, getting people to want to work, that show up for work, can drive our trucks. I mean, it's an ongoing, always a problem. So once we get good people, we pay them well, we have good benefits, things like that. It's important, but they have to work.
You said there's installers and technicians. What's the difference between an installer and a technician?
Well, the installers are the ones out installing the equipment, putting in the ductwork, they'll braze the lines, hook up the controls. The technicians are mainly doing the startups when we're done with an install, or they're out repairing old equipment. Troubleshooting, things like that, correct.
Hey, to what level is software utilized in designing whole house systems? Is it or is it still just kind of like,
It depends on the company. There's a lot of companies that don't use anything and they just kind of wing it, and it's not an accurate way to do it at all. I use a program made by RightSoft, and it's a manual J program where I actually input into my computer everything I can about the house, every room, the room heights, all the insulation levels, the windows, the orientation of the house, how many people are in certain rooms.
Whoa.
It takes all that into account, and then we can tell the system if it's a ducted type system, or if it's a ductless system. That's completely different load calculations. Because if it's a ductless system, the equipment and the conditioned air is in the conditioned space.
Oh.
If you have ductwork under the house or in the attic, it has to account for that loss through the ductwork. So on this house, for instance, we have a ducted system downstairs, and we have no ducting upstairs. So different loads between the two levels of the home. On this home, the beauty of this system is we have a completely separate system for downstairs versus upstairs. So the downstairs temperature control is completely separate from anything upstairs.
Yeah.
And then upstairs, we have a 4-zone mini split going in, so every bedroom can have a different temperature setting.
Yeah.
I mean, I think high efficiency equipment is great, but it has its drawbacks as well. Some of it's very complicated. When it fails, it can be very expensive to fix. It's expensive. A lot of people just can't afford it.
Yeah.
And that's why the ductless systems are great, because you're getting the most efficient thing that's on the market, and the cost is very low comparative to a ducted type of a system.
Yeah.
And then you also have the benefits of the true zonal control in the house. But honestly, it kind of comes down to what people can afford. And then, for us in this area, we're not in a big metropolitan area. Not everybody can spend $20,000 on a heating system. So we have to kind of roll with that and figure out people's needs and go with that and give them the best we can for what they can afford.
Yeah. With these mini splits, why is it that they are like so much more efficient? Is it because they're not blowing air through the ducts and wasting that energy? Is that like where like the real where is the magic with those things?
Well, it's that's a large part of it, because you have no loss. Basically, on a mini split, everything the heat pump produces, you're getting in the house. With a ducted system, no matter how good of a duct system you make, you're going to have some radiant loss through it. It's just
like through the duct. Like the
you're
duct's
just
getting cold.
Yeah,
and, okay.
Right. You're just, and maybe it's minimal, but you're going to have some no matter what.
Yeah.
I think the biggest thing is just the technology of the mini splits. They have the variable speed compressors, so they're designed to maintain temperatures in the house. The compressor actually ramps itself up and down and varies its output based on the needs of the house.
Yeah.
So I think the biggest problem we've had with mini splits is getting people to use them properly. You have to find a temperature that you like and basically just leave it alone. Let it ramp up and down, let it maintain a temperature. You don't want to let the house get freezing cold and then fire it up, because they're not designed to rapidly heat the house. They're not designed to rapidly cool the house. If you know it's going to be a hot day, You leave it on, maybe set it for 74 degrees, let it ramp up and down and do its thing, and then you're comfortable. You don't have to worry about it.
People will treat it like a fan where they're like, I'm hot, and they'll
Right.
like slam
And
it.
that's the worst thing you can do. Yeah.
It's the worst thing.
It's the worst thing you can do.
Interesting. Better just set it, forget it,
Yeah.
and just
Exactly. I always say find your happy place with your remote control, find your setting that you like, and just leave it alone.
yeah.